Hello all, so let's proceed with the daily problem for today. And it says about lexicographically minimum string after removing the stars. So what the question says is, we have to find the lexicographically smallest. So let's see what's lexicographically smallest first. Okay, so quickly let's see what does it mean. So for example, let's say I have two strings. Okay, let's say this is string S and this is string T. So these are two strings that are given to us. So if someone asks which one is lexicographically smallest, then we will say that it's S. Why? Because we have to see the first differing character. Okay, so here the first differing character is this one in both. Now in S, A occurs A occurs first, right? I mean A occurs lexicographically in alphabetically. I mean A is smaller, right? A comes first and B comes later, right? So whatever comes first, right? It's considered as the lexicographically smallest. Okay, that's why this S is lexicographically smallest. So the definition is also given here. If you will open this pop-up, that you can see that string A is lexicographically smaller than string B. So here they are denoting A and B as strings rather than S and T. So if in the first position where A and B differ, that's what I said, then string A has a letter that appears earlier in the alphabet, right? Alphabetically, whatever letter, the differing letters, okay, in which of the string, either A or B, or in our case, S or T, whatever is the first differing letter, okay, the string that has the first occurrence or the earlier occurrence in terms of alphabetical order of that differing character is considered as lexicographically smaller. And what if both strings have same length and there is no differing character, right? Then the shorter in length is considered. So it's also written in the definition. So now let's come to the question. That the question says we are given a string and there is some rule. So it contains as many number of asterisk or star, you can say. And our task is to remove all these characters, that is all these star characters. But the rule is, do the following operation. When there is a star, how can you remove that star? That delete the leftmost star. Along with that, the smallest non-star character to its left. So what it says is, whenever there is a star, we have to remove that. Okay, but along with that, the smallest non-star character to its left. So if there are several smallest, then you can delete any of them. Okay, so what it means is, on the left side of this star, we have to return, or we have to delete the character as well. Okay, but to its left and the smallest. So two things are important, that we have to remove the smallest one and also smallest on the left. And if there are several smaller, you can delete any of them. But the condition is that we should delete any of them in such a way that we should return the lexicographically smallest. Okay, so what it means, it might be a bit complicated. Let's understand here. So this is the same example that they are given. So here the output will be AAB. So what we will do is we will remove this A. Now, why this A? Why not any other A? Firstly, let's go step by step. So firstly, let's see, whenever we encounter the star, they said that remove the smallest one, okay, on the left of it. So obviously, what is smaller in between A and B? Of course, A. So we can't remove B. We have to just remove A only. So we can remove either this A, or this A, right? But we have to remove or pick the A that we have to remove such that in the output string, it should be lexicographically smallest. Okay, so for example, let's say I remove the very first one. Then what we will get? We will get ABA, because star is removed and the first A is removed. Okay, when I remove the first A. Okay, now let's say when I remove the second A, then again I'll get ABA, right? Because we'll also remove star. And now let's say I'm removing this one. Then what I'll get? AAB. And among these three, which one is lexicographically smallest? As per our discussion, we know that this is the lexicographically smallest. Okay, and that's why best thing is to remove this A. So in general, what we have to do is, from this example, we can say that, and it will work for all the examples, that we have to remove the lexicographically smallest Okay, but the rightmost occurrence. Okay, if there are multiple occurrence, we can delete any of them, but here we can't delete any of them. We have seen that to get the lexicographically smallest string, we have to remove the rightmost one. Okay, so rightmost, I mean from the right side, from the end of the string, we have to see whatever is the rightmost. Now, what can be the intuition to approach this problem? Of course, it's saying that we need to somehow monitor whatever is the smallest one, right, on the right side. Okay, so what we can do is we can use a stack, or I can say min heap. That will be better. And why min heap will be better? Because I have my heap videos. Okay, so please go check out in the data structure and algorithm playlist. So how the logic develops, let's see that. So firstly, we will start iterating, and let's say we are getting a. Okay, now again we are getting a. Now in order to distinguish that these two a are different, we can store the index. Okay, so let's store the index. So I'm storing the index as well. So now this is index 1. Now comes b. Okay, and we know that b is obviously it is coming at index 2, but we know that it's a min heap, so it will maintain minimum on the top, correct? So what will happen? There will be a heapify operation, and after this heapify operation, what will happen is b should be, so let's modify here only. So this b won't be here because is the a is smaller. Okay, so let's remove everything, and it will be, we will be at the very end. Okay, so it will be, oops, b and 2, then above it will be a and 1, and on the very top will be a and 0, correct? Now again comes a, but this time, so why this 0 and 1 occur? Because if these two characters are same, then we have to check which one is minimum from this and this. Okay, and we know that this one is minimum. Okay, but here we don't have to check the second entry because we directly know that b is greater, so we will put it down. Okay, it's in terms of ASCII value. Okay, so a has ASCII value of 97 and b has 98, and that's why it's greater, and that's why it's on the bottom. Now again comes a, and the index is 3. Okay, and obviously since this is not possible, right, there will be a heapify operation, and what will happen is, let me draw this here now, that b2 will remain the same, but now comes a3. Okay, and then there will be other two, which is a1 and a0. So a0 will always stay on the top. Okay, so one problem is that we have to remove a, but not this on the 0th index. We have to remove the one from the 3rd index, right? So it's good if we can have this on the top. Okay, so that we can access it directly using o, just with O of 1 operation, O of 1 time complexity, right? So rather than storing, because if we will store index like this, it will be not good, because then it will, because it's a min heap, so the problem will be that this will be on the top, and if it will be a max heap, then b will be on the top, correct? And we know that from amongst a and b, we always need the one, because the question already said that remove the smallest one. Okay, on the left of the star, remove the smallest one. So among a and b, we have already seen that a is smallest, so we can't remove b. So what can be the solution? The solution is, rather than storing the index as positive, let's store them as negative. So let's see what happens when we store index as negative. Let's start from the scratch. Okay, so first comes a, so let's have a and 0. Negative 0 doesn't exist, so it's a0. Now comes a, and the index will be -1, and obviously -1 is lesser than 0, so it will stay on the top. Then comes b, and the index will be -2, and we know that we will see this one, right? So rather than b on the top, b will be on the bottom. So let's draw it on the bottom. That b will be here with -2. Then comes a with -3. and it will be on the top. So we can remove it directly. So what we will do is, as soon, so we will, what we will do, we will iterate, and as soon as the star comes, we will pop the first one. So firstly we'll have the 4 characters, so it will fill the 4 characters, and now there comes the star. So as soon as the star comes, what we have to do, we have to simply remove this character. Correct? Now what we will do is just use the rest of the characters in the heap, okay, to generate the, because we have the index as well, right? It's 0, then obviously we have to consider it positive because we just negated for the heap operation. So this will be at first index, it will be at second index, so it will be A and B. That's simple, our answer. Correct? So it's so simple. So simply what we can do is, let's go to the code. So as I said, we need min heap. So let's remove this code and I'll do it step by step. So let's say we have to first consider min heap. So it's a min heap now, and we have to iterate over our string. So let's say we iterate I comma c in enumerate our string s. What happens is, firstly, now we have to check if my character is star, then we have to pop. Okay, so but if it's not, then what we will do, else simply we will push it. So heap q dot heap push, what do you have to push? The character along with its index, but the negative index. Okay, so firstly we will populate our, because every time it will go to the else until the star comes, because whenever star comes, then only we have to do that. If there is no star, then we don't have to do. And if it's star, it's on the leftmost, then it won't, right, it won't execute. Okay, so here it's written that the input is generated such that it is possible to delete all star characters. Okay, so star won't be on the first, won't be first. Okay, there will be some leftmost character. Okay, so they have already given the input or the test cases such that this is possible to delete the star. Okay, so the star won't appear at first. Now what we have to do is, we have to pop first. So heap q dot heap pop our min heap, and obviously here I forgot min heap because we have to push on min heap, and what we have to push, it's here. So here it will give two things when we pop. Firstly will be the character, popped character, and second will be its index. Okay, these two things will be there. So popped character and popped index, and this is the one we have to delete, right? So what we will do is, we will put it in one set. It's just its index. Okay, we will put it in one set. So let's call it the delete set. So delete dot add that index, but again we have to make it positive. While adding we are making it negative, but here we'll again make it positive. So let's take one set. So it will store all the index which needs to be deleted. So after this operation, what will happen is, let's see, let's print our deleted, and let's print our heap. Okay, and just see what happens under the hood. Deleted, my bad. Obviously it's a wrong answer, but what will happen is, you can see that 0th index, first index, and second index, only this remains, and what we have to delete is at the 4th index. You can see this is at the 4th index, 0, 1, 2 and 3. Correct? Oh, sorry, it should be idx. It should not, it will be at the third index, not fourth. Fourth index is the star, right? Sorry. So let's run again. idx is not defined. Where is it? Popped idx. So this thing happens. So you can see this will be the deleted index, and this is what we have to simply. So what now we can do is we can iterate, and using this index we can do this, or what we can do is let's just focus on this index that we have to delete, and also focus on the stars. Okay, so whenever there will be a star or this index, simply we will ignore that, and rest of the string we will put it. So let's have our result string, and we have to iterate again. So again, in enumerate, so if my character oops equals star, or if my id in deleted, so if it's the index that needs to be deleted, we will just ignore. Okay, we will just ignore this iteration. Else what we will do is we will add result.append that particular character, and at the end we have to join. So join with no space the result, and it will be returning to us the list, or sorry, the string. So it's accepted. So you can see, and we can remove the print statement, of course, but let it be. And let's see now the most important part. What's the space and time complexity? So coming to space, we can see that we are enumerating towards the entire string s. So let's say if it's of length n, and what we have to do is for each character that we are enumerating, there will be a heapify operation that happens to adjust and have the minimum on the top, right? So let's say in worst case we have all the characters in our string, and there might be repeat characters, so it can't be like just 26 characters will be there, because there is a constraint that string contains only lowercase characters, but it won't be like just 26. There will be a lot of repeats of a's and b's, right? Like here we have a lot of a's, there can be n number of a's. So that's why it will be a log n operation, because we know that heap takes log n operation for heapify. So n times for every character it's happening log n. So this will run for n times, because let's say if string of length is n, then it will be n log n, and that's why n log n. And again we have to iterate once. Okay, but the higher terms matter, so it will be n log n asymptotically, but exactly it will be n log n plus log n. And space, we are using min heap, and there will be a lot of characters. This will be constant, and this is not considered, right? Because it's a result string. So this might this we won't consider, or you can consider as well, but it's not considered in most of the cases. So this will take O of n, okay, because we can put all the characters on the heap, and this will be just O of 26, because or no, it won't be O of 26. It will be also like, because there will be a lot of indexes that we can delete, right? So let's say we can delete all the characters. There will be equal number of stars and characters, and we have to delete all of them. This will also be at the end. We can say that it's O of 26, or O of 1, or O of n, right? So or it will be O of 1 or O of n. Let's see that. So for example, if I have to delete one character, then it will delete second character, and there will be a lot of n. Yeah, it should be O of n, right? Because we can delete a lot of characters as well. There are a lot of all the occurrence. It won't be like just 26. We can delete a lot of them, right? So as many number of stars are there, we can delete. So it depends on number of stars. So this will be taking O of n. This will be also O of n, so it should be O of 2n. And if we consider the result as well, it should be O of 3n. The result is not considered, so that's why asymptotically constant doesn't matter, so it's O of n. Okay, so that's the simple logic. We can further optimize it as well, but I don't think it will be a much of the optimization. So that's it for this video. So stay tuned and thank you.